All right, so if you haven't taken your test from last week yet, make sure you get that done as soon as possible. I do have, my classes are graded, but they're not in the grade book. They will be in the grade book within the next hour and a half, okay? Because I'm in the resource center after this, so that was when I had scheduled time to install, or not install, input my grades into the grade book, so they'll be in there very shortly. Only thing that's not graded yet is the extra credit, because that wasn't due until yesterday, and Schmeling and I haven't talked about how we're going to grade that yet. So that'll be shortly, because there weren't that many in there, so, and that's a quick grade. So yeah. Looking ahead again, we're in our note packet today. So if you want to be in there, that's great. We'll pick up where we left off yesterday. And then, looking at the rest of this week, we'll talk unit circle today. We'll develop the unit circle. We'll read the unit circle today. And then tomorrow and Friday, you'll spend some quality time dealing with the obviosities of the unit circle and things that you probably know. That it's obvious things that you probably know, but you might have to think to actually know them. It's always by the door when you come in. It's literally on the board that says, if you weren't here yesterday, pick one of these up. But look, read the board. Read the board. What does it say?
I read it.
Yeah. Okay. Then next week we'll be doing more with applications and reference angles and coterminals. But most importantly, next week, Thursday, is your unit circle memorization quiz. One shot, summative, gotta know. Okay? Okay? Here we go. Okay? So yesterday we ended with talking about 4 of the Sweet 16. So we ended with this one was at 1, 0, which was 0 degrees or 360 degrees, which was 0 radians or 2 pi radians. Okay? So that was where we were at for that one. Then we said that this up here was the point. Again, you have all of this from yesterday. This was the point 0, positive 1. It is 90 degrees. It is pi over 2 radians. Then we came over here and we said that this was the point negative 1, 0, which was the point, or which was 180 degrees or pi radians. And then we came down here and we said this was the point 0, negative 1, which is 270 degrees, which is 3 pi over 2 radians. Okay? So that's where we were at yesterday in the start of development. Okay? All right, here we go. Now let's talk quarter points. So to develop, let me back up one slide. To get this point, to get that it was 360 degrees, we went all the way around the circle. To get this point over here, to say that it was 180 degrees, we went halfway around the circle. So we went half of the circle. Then we went half of the half to get the 90 degrees. Okay? So let's go half of the half of the half to get our quarter point. So all the way around, half of it would put us over here. Half of that would put us over here. Half of that puts us right there. Okay? Now that is a special point here in our, or on our unit circle, because, oops, I don't need that. I wanted this, and then I wanted to go here, because what kind of a triangle gets made here? It's a right triangle, yes, but even more importantly, it's a 45-45 right triangle. It's an isosceles right triangle. Which means, then, that this would be at the point, or at the theta measure here, would be 45 degrees. Okay? Half of 360 is 180. Half of 180 is 90. half of 90 is 45. So half of half of half. Half of half of half of 2 pi would be pi over 4 radians. Now let's figure out the coordinates of that triangle. We know that this is a 45, 45, 90 triangle. And yesterday we remembered our special right triangles from whence we were trees. And we said that the hypotenuse of our 45, 45, 90 triangle was x times the square root of 2, where x is either one of the legs of our triangle, because they're both the same, hence it being isosceles. Okay? What is the hypotenuse of my green triangle right here? It's 1, because we're on the unit circle, so this length here is 1, so x times the square root of 2 has to equal 1. A leg times the square root of 2 gets me the hypotenuse. In this case, the hypotenuse is 1. So then we can divide by the square root of 2. And then because we are on the unit circle, we will always rationalize our denominators. So then that gives me that x here is equal to the square root of 2 over 2. So both of these are the square root of 2 over 2. Which means that the xy coordinate here would be the square root of 2 over 2, comma, the square root of 2 over 2. Now, the wonderful thing, and I'll tell you more about this later when we're talking about actually memorizing the unit circle, the wonderful thing about the unit circle is everything is reflective in the unit circle. So I can reflect this green triangle over the y-axis, and that would put me at this point right there. Which would, and knowing the fact of what I know about a Cartesian coordinate system, where all points in quadrant 1 are positive, positive, all points in quadrant 2 are negative, positive, all points in quadrant 3 are negative, negative, and all points in quadrant 4 are positive, negative. Knowing that, then the coordinates of this point would be negative square root 2 over 2, comma, positive square root 2 over 2. I cut quadrant number 2 in half, so quadrant 2 is between 90 and 180, so the halfway point there would be 135 degrees. I cut pi over 2 radians and pi radians in half, so the radian measure here would be 3 pi over 4 radians for that. Now I can reflect it not only over the y-axis, but then I can also reflect it over the x-axis at the same time, a double transformation, if you will, that puts me right here. That would then be the coordinates negative root 2 over 2, comma, negative root 2 over 2. I would be cutting the third quadrant in half, so that would be 225 degrees, or 5 pi over 4 radians. And sometimes you don't like your 5s, so then you just rewrite them. I can take my green triangle and I can reflect it just in the x-axis, and now I cut quadrant number 4 in half. So that would give me positive root 2 over 2, comma, negative root 2 over 2. Cutting it in half would be 315 degrees. Cutting it in half would be 7 pi over 4 radians. And those, ladies and gentlemen, are our quarter points. Questions on those? Next, we move on to our third and our sixth points. Which do you want to do first, thirds or sixths? Thirds first, okay? So if I am cutting it into thirds, okay? So basically I'm cutting pi into thirds. That would be pi over 3, okay? So that gives me 60 degrees. So I am up here at 60 degrees, or pi over 3 radians. Here now is my triangle, which puts me at a 60-degree angle here. If I again make a right triangle, what is my missing angle measure? 30. Oops, that's one of our special ones from yesterday. Then, hence why we learned those yesterday. Okay? So now, once again, my hypotenuse is 1. Yesterday, we learned that the short leg, we'll call it X in this case, the short leg was the hypotenuse, yes, was twice the short leg. So I would have 2x here equals 1, which would make then my short leg 1/2. We also learned yesterday that the long leg was the short leg times the square root of 3. So that would make my long leg 1/2 times the square root of 3, or the square root of 3 over 2. Which makes the coordinates here be 1/2, comma, the square root of 3 over 2. Again, reflecting it in the y-axis puts me to here. That would be the coordinates of negative 1/2, comma, the square root of 3 over 2. It's 60 degrees more, so that is 120 degrees. It's pi over 3 more, so that is, 2 pi over 3 radians. We're up there. Double reflection puts me down to here. That would be negative 1/2, comma, negative square root of 3 over 2. 60 degrees more puts me at 180 degrees. 60 degrees more puts me at 240 degrees, or 4 pi over 3 radians. reflecting it over the x-axis puts me here. That would be positive 1/2, comma, negative square root 3 over 2. That would be at 300 degrees, or, oops, a bad 5 again. Sometimes you just gotta write your 5s, goofy. 5 pi over 3 radians. The nice thing, actually, I should pause here to make sure you're all caught up. Everybody good on that? Yeah. The nice thing is that you can also take that 30, 60, 90 triangle and you can spin it around on its side and you can make another 30, 60, 90 right triangle right there. Where now, here is your 60 degrees, and here is your 30 degrees. All of this math is going to stay the same. It's just going to say now that this point, so this side would now be the 1/2, this side would now be the square root 3 over 2, so this would be the point, the square root of 3 over 2, comma, 1/2, and we would be at 30 degrees, or pi over 6 radians. And now all the reflections can happen. So here would be negative square root 3 over 2, comma, positive 1/2. This would now be 150 degrees, or 5 pi over 6 radians. Down here, it would be negative square root 3 over 2, comma, negative 1/2. It would be 210 degrees, or 7 pi over 6 radians. Over here, it would be square root 3 over 2, comma, negative 1/2. It would be 330 degrees, and it would be 11 pi over 6 radians. So let me jump ahead here now to get to this one. So next week, Thursday, you will be taking the unit circle memorization quiz. Okay? One attempt. It's not formative. It is summative. Okay? You need to know all 16 coordinates, or all 16 points. So that's an X and a Y for each of the 16 points. You need to know the radian measures for all 16 on the unit circle. And you need to know the 6 trig identities that we learned yesterday. So, with that being said, let's go back here to this page. You should have a reference page sheet. It's 2 pages ahead in your notes. Okay? It looks just like this. It is literally just a blank unit circle with the 6 identities at the bottom. Okay? So that page is your unit circle quiz next week, Thursday. Okay? So you will need to fill that page in next week, Thursday, exactly how that looks. That's almost I think we even took, the only thing that we didn't put on there is, like on your unit circle quiz, we actually have the parentheses for the points and a little blank for the radian measure of them at each of the spots. Okay? So, but otherwise it's much one and the same. Okay? So, if it were me, or the first time that I memorized the unit circle quiz, okay, or the unit circle, I just memorized quadrant number 1. Because everything else reflects. Okay? So if we're just memorizing quadrant number 1, the first point that I memorize is this one. 1, 0, and it was 0 radians or 2 pi radians. I memorized it as 0 degrees and 360 degrees also, but for purposes of your memorization quiz, you just got to memorize the radians. Okay? Then I went up here and I said, this is 0, 1, or pi over 2 radians. I also said it was 90 degrees. Okay. Then I went here. Here it was square root 3 over 2, 1/2, and that was pi over 6 radians. After I get them all in there, I'll show you how I really memorized it. Okay. Then went here. Root 2 over 2, comma, root 2 over 2, pi over 4. Then here, one half root 3 over 2, pi over 3. Let's fix that one because that was a really bad 2. Okay. Here's how I memorized it. I started with the y's. Actually, we can start with the x's. 0, 1, 2, 3. 0, 1, 2, 3. Okay? So 0, 1, 2, 3 work in both ways. Okay? Okay? Really, you could memorize it as the square root of 0 over 4, which is 0. The square root of 1 over 4, which is 1/2. The square root of 2 over 4, which is the square root of 2 over 2. The square root of 3 over 4, which is the square root of 3 over 2. The square root of 4 over 4, which is 1. Okay? And then working back the other way. Okay? There's that trick also. Okay? And then everything after that in terms of points is just a reflection. So here, this one would be negative 1/2, comma, the square root of 3 over 2, which would be then 2 pi over 3, or 120 degrees. This one would be negative square root 2 over 2, comma, square root 2 over 2. Bad 2 again. Or 3 pi over 4. Or 135. Next one would be negative square root 3 over 2, comma, 1/2, which would be 5 pi over 6, which would be 150 degrees. Next one would be -1, 0, which would be pi, which would be 180 degrees. Good on that so far? Because I can't get both top. I can't get the top half and the bottom half all in the same picture. So I got to make sure you guys are good on that one before I scroll down. All good? Then the next one would be -√3 over 2, -1/2, and that's going to be 7 pi over 6, or 210 degrees. Next one is going to be -√2 over 2, comma, -√2 over 2, or 5 pi over 4 radians, or 225 degrees. Next one is going to be -1/2, comma, -√3 over 2, or 4 pi over 3 radians, or 240 degrees. Next one is going to be 0, -1, or 3 pi over 2 radians, or 270 degrees. Okay, so kept the same color scheme, didn't I? Yep, good. Pinks and purples always get me confused. Next one would be 1/2, comma, -√3 over 2. It's going to be 5 pi over 3, or it's going to be, not 200 anymore. We're out of the 200s now. We're into the 300 degrees. Next one is going to be √2 over 2, comma, -√2 over 2, or 7 pi over 4 radians, or 315 degrees. Add 2 again. Bad negative sign too. Let's fix and fix. Good negative sign, get a good 2. There we go. Now I feel better about myself. And the last one is going to be 330 degrees, which is going to be +√3 over 2, comma, -1/2, which is 11 pi over 6 radians. Okay? So that is your unit circle that you need to memorize on top of what we talked about yesterday. So the cosine of t is equal to what? X. Yep, it's equal to the x part of that point coordinate. Okay? The sine of t is equal to what? That'd be the y part then of the coordinate. The tangent of t would be equal to not x over y, y over x. Yep. Okay. Secant is the reciprocal of cosine, remember everything needs a co, so that would be 1 over x, or flip that fraction. Cosecant, everything needs a co, would be the reciprocal of sine. Cotangent, everything needs a co, would be x over y. So let's utilize our unit circle now, and let's read it. Let's evaluate different values at certain angles. Okay? So if I say the sine of pi over 6, okay, that means then, first off, you have to find pi over 6 in terms of an angle. And then sine is what? Again? Sine is the y part. Okay? So I need the y part of the coordinate at pi over 6. The y part would be 1/2. So sine of pi over 6 then is 1/2. What would the sine at 11 pi over 6 be? Do we agree with negative 1/2? Y part 11 pi over 6 would be negative 1/2. Okay. Cosine is x, y, y over x, x over y, 1 over y, 1 over x. What is cosine? X. Okay. So what is the x part of the coordinate at pi over 4? Square root 2 over 2. Cosine at 5 pi over 4. Negative root 2 over 2. Cotangent at 3 pi over 2. Well, we just said that the cotangent of any angle was equal to x over y, right? What is the x part at 3 pi over 2? 0. What is the y part at 3 pi over 2? Negative 1. 0 divided by negative 1 is 0. Yep. So the cotangent at 3 pi over 2 is 0. Okay. Let me ask you this. Bonus question. We'll call it 5.5. What is the tangent at 3 pi over 2 then? So that one would be negative 1 over 0, right? And we can't divide by 0, so we're going to call that one undefined. Okay? Undefined for that one, because we can't divide by 0. Okay? Cosecant at 3 pi over 4. Cosecant was 1 over y, correct? Reciprocal of the sine, yes? Okay. So that's going to be 1 over 3 pi over 4. The sine is root 2 over 2. Or the reciprocal of root 2 over 2 is 2 over the square root of 2. With me on that? Because we are on the unit circle, we rationalize our denominators. So we have no radicals in our downstairs, in our denominator. So I'm going to multiply this by the square root of 2 over the square root of 2. And that gives me 2 square roots of 2 over 2. Or simply put, the cosecant at 3 pi over 4 is just the square root of 2. Questions on that one? When you get into some more complicated problems like number 7 here, it helps to just break them down into their individual parts. So for instance, the first part is cosine squared at pi over 3. What is the cosine at pi over 3? 1/2. So we need to square 1/2. And 1/2 squared is 1/4. So that one is just 1/4. Secant squared at 5 pi over 6. What is the secant at 5 pi over 6? So what is the secant at 5 pi over 6? Negative 2 over the square root of 3. And I need to square that. Okay. Reciprocal of cosine. Secant is the reciprocal of cosine. The cosine at 5 pi over 6 is negative root 3 over 2. What is negative 2 squared? 4. What is the square root of 3 squared? 3. So that's just 4/3. Then I've got the cosecant squared at 7 pi over 6. What is the cosecant of 7 pi over 6? Negative 2. Negative 1/2 reciprocal is negative 2, correct? Okay. Negative 2 squared then is 4. With me on this. Okay. Adding and subtracting fractions, what do I need to have? Need to have a common denominator. So what is my common denominator going to be? 12. Okay. So 1/4 is 3/12. 4/4 is 16/12. And 4 is 48/12. Now that I have common denominators, I can add and subtract the tops. 3 plus 16 is 19. 19 minus 48 is negative 29. So this would be negative 29 over 12 for that answer. These are just real numbers, so no labels on this. Okay? Again, I remind you of 2 things. Thing number 1 is next week, Thursday, you will have your unit circle memorization quiz on this. And I also remind you that you should be now, homework-wise, you can do up to page 3. Okay. So front, back, front.